In this video, we continue our efforts to use the NOAA data and Spark to try to find climate zones. So we've decided what data we want to have for these climate zones. And it's interesting to note that if it weren't for these last two, I'd probably use a very different approach than what we're about to do. You see, all of these other values could be calculated nicely from the data frames that we have. And so, and using a group by. And so we could take a group by and use aggregation to get averages or standard deviations. So the averages and standard deviations are great. However, in order to get the seasonal variation, we have to run a linear regression on it. And the linear regression is basically not something that we can easily do on the elements from a group by. So instead, we're writing this method down here that just takes the kind of the individual elements from each cluster and does some work on them and is supposed to give us back one of our cluster data values. Okay, yeah, we'll go with this for now and then see where we run into problems. So the first thing I need to do is I want to get down to a reduced set of data, which is only going to include that data frame where it is of the appropriate cluster. So the cluster column has to be equal to the cluster that was passed in. Turns out I'm going to do quite a bit with this, so I'm going to cache it. I'm also, because I don't want to keep these things around, filtered data dot, I'm going to unpersist it. Okay. The other things that I need in here are I'm going to need just the max temperatures, just the min temperatures, and just the precipitations. And so I'm going to go ahead and give those some names. So the Tmax is, I'll make it plural by adding an S, is my filtered data dot, and I will filter this again where I want the measure to be Tmax. And so Tmax was one of the strings that was used inside of the data file to indicate that a given value is a high temperature. We're going to use that a few times, so I'm going to cache it as well. I'm going to do this twice more. I want to do it for all the minimum temperatures and for the precipitations. And so Tmin and PRCP is the value for precipitations. And since I'm caching them all, I should unpersist them as well. Copy, paste, 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 and Tmins and precips. Then I want to calculate the values that would be used to give me back the cluster that I want. So to start off, we'll just do the latitude and the longitude. So how would I get the latitude? Well, for this, I'm actually going to use the full filtered data. And all I need to do is aggregate it so that I get the average value for the latitude. I might also want to get the, how about we call this lat data. So I want to aggregate this. I want an average of lat, and I'm going to call that lat just because it'll be easier in the name that it would give it by default. I also want the standard deviation of the latitude, and I'll give that a nice name as well. Filtered, apparently I'm missing a D there. And I want to pull out those values, which I couldn't do in one statement because they're going to be separate. So the latitude for my data point is going to be lat data dot select the column lat using this name right there, which we happen to know is a double. And turns out there's only one value that came through the aggregation, so I'm going to pull that off with dot first. And we'll do the same thing to get the standard deviation of the latitude. And then we're going to do this same process for the longitudes. Longitude, longitude, longitude. Let's see how many places I have to change. AT to ON. And it looks like just those. Okay, so I now have all of my latitude values and my longitude values, and just to make it clear, I am going to have a val for, I'll call it CD for the cluster data, and it takes the lat, actually first it takes the cluster, and then lat, and then lon, and then lat std, and lon std, and then a whole bunch of other values. We have them up here: max, min, standard deviation of max and min, precip, and variations. 1, 2, 3, 4, 5, 6, 7 more values. 1, 2, 3, 4, 5, 6, 7. And at this point I can fill in the bottom here and say CD. Okay, that gives us another nice step. We can come back and talk about what we need to do to get the temperature values out, and then we can use this method we wrote earlier to get the seasonal variations. Once we have that in place, we will definitely want to test it. We've been doing too much coding here without running anything, so let's try to get to the point where we can test this and at least see one data point for one cluster.